Hello everyone, good morning. So I'm Mariano, I'm a software engineer from Buenos Aires, Argentina. And today I'm going to talk about home automation with RasperryPi, Node.js, and Arduino. So internet-connected devices and home automation has been a growing field over the last several years. And big companies are betting hard on them. More and more people are starting to adopt this kind of devices. For example, how many of you have some sort of home automation device at home? Maybe like a thermostat, tuning alarm, light control, anything? Okay, a lot. For me, these devices fall into two main categories. On one hand, we have commercial products. We have stuff like Nest, the whole Philips Hue line. Samsung with smart things is also really big. We have Amazon with the dash button and now the Amazon Echo. And on the other hand, the maker movement has also been growing very fast, and it's making open hardware better and more accessible. So there are a lot of development boards that let makers build their own home automation devices. Just do a quick search on instructables for home automation, and I guarantee you will yield endless results. So this is a big indicator of how much movement is around this topic. So moments ago, I asked how many of you had some sort of home automation device. Now I want to ask how many of you have more than one? Okay, a few, yeah, that's okay. Then you will know what I'm talking about. So this growth has given us a home field with home automation devices. Some of them commercial products, some do-it-yourself projects. And usually each of them has their own unique way of controlling them. Some have custom mobile apps, some have their own websites, some are only accessible from within your network, and some can be accessed from outside your network. So when you start adding features to your home, it's really easy to end up in home automation chaos. And while some commercial products play nice with each other and have really good integrations between them, that's not usually the case for do-it-yourself projects, as they are usually conceived as standalone projects. So it seems that we need some centralized way of controlling them. Of course, there are a lot of ways we could do this. All of them are valid. And we need to realize that each of them has advantages and disadvantages. So when we're thinking about doing this, it's important for me to know which goals do we want to achieve. So for me, the main goals we want to achieve is, or I want to achieve, it's being able to connect to both commercial products and homemade devices, because if you already have some commercial product at home, like Nest or Philips Hue light bulb, you will definitely want to connect with them, because they're usually really great at what they do. But also, I want to connect with do-it-yourself devices, because let's face it, they're just really fun to do. But on top of that, I believe that they will add a degree of customization to your home that no commercial product can match, really. I also want the system to be developer-friendly, that is, being able to easily add new stuff and to be able to hack it. And I want it to be cost-effective. So let's see what these goals actually mean and how can we accomplish them. So this is not just a fancy way of saying cheap. Really what it means is don't spend more money than you need to, which in turn translates to don't have hardware you don't need. And this is especially important for processing capabilities and communication hardware. So I think this is an easy one, at least in a Node conference filled with Node developers. we'll just use Java. No, wait, sorry. No, of course. But jokes aside, I really believe that Node is the platform that best fits the needs of an IoT project. It's really easy to create prototypes with. It runs on many embedded devices like RasperryPi, BeagleBone, the Tessel, and so on. It has an infinity of modules available for you to use that you can leverage. There was a great talk about that yesterday. And it also has excellent tooling, and most important of all, it has a great community behind it. That's actually a big deal. So in terms of platform choice, we'll bet on JavaScript. And for our hardware platform, we could use many things. We could use stuff like RasperryPi, BeagleBone, Tessel, on other developer boards that just runs on Linux. We just need to be powerful enough. We need to run Node, of course. We want it to be cost effective. So I ended up choosing RasberryPi. It is powerful enough. It runs Node, it runs Linux, which for me it's a plus because I like Linux. And it has good connectivity, at least for the purposes we need. I also chose it because there seems to be more community around it and more movement than the rest. That's always a good thing. Also, it was much easier to get one of these in Buenos Aires than the rest, so that was a plus. So installing Node on Raspberry Pi is pretty simple. You can just download the tar file from Node.js.org. This is especially has become more easy since ARM support was added natively since Node 4.0. Or you could just use the convenient repository from Node source and just install it via the package manager. So another important goal, as I mentioned, is being able to connect to commercial products. They're really good, really, at what they do, and if you already have them, you will want to connect with them. Luckily, most of these commercial products, or at least the big ones, already have APIs that we can use. It's pretty easy to connect with them. Usually, they're just REST-like APIs, so it's pretty straightforward to interact with them with Node. And also, several of them have Node packages already built that makes things even easier. So I think having chosen Node as a developer platform, it's already paying off. Another big part of the system, and for me it's the most important one, is being able to connect to do-it-yourself devices. For those who don't know, do-it-yourself devices is just stuff that you make, like the cocktail robot that was just on the talk before. And here we have a lot of freedom, right? We are building it. So we have a lot of options, ranging from wired, like some serial stuff, or I2C. We can also use raw radio frequency. We can use some protocol on top of that, like XB or Bluetooth or Wi-Fi. So taking into account two of the main goals I mentioned, that is that the system needs to be developer friendly and it needs to be cost effective. I opted for a solution based around Arduino and the HC06 module. That's a Bluetooth module. You can easily add to any Arduino. So in terms of development, this approach gives us a lot of flexibility, because with this Bluetooth module, we are just creating a serial link via Bluetooth with, between the Raspberry Pi and the Arduino. And this gives us the ability to wirelessly control the Arduino we did JavaScript with 25 on the Raspberry Pi side. And this is a big win because, of course, we all love 25. And in terms of being cost effective, this works well too because Arduinos and this Bluetooth module in particular are widely available all over the world at really low costs. So this works well. And of course, at scale, it will also work well because for each Bluetooth dongle that we have on the Raspberry Pi, we can connect with up to 7 different devices. So if we are just using the Raspberry Pi for this and we have all the USB ports available, we could connect with up to 28 different devices. And that's a lot. I didn't test it with that many devices, of course, but if someone does, I would surely like to know. And here's an example of how you would implement a temperature sensor with Johnny 5. You would just create the board specifying on which port the serial link connection has been established. You would just, when the board is ready, create a thermometer object specifying which type of sensor are you using. And then you're just able to receive the data event and do stuff with the temperature. I mean, I think it can't get much easier than this. Another problem is what happens when you need native Arduino, right? So 25 is very cool, but maybe you already built your device with native Arduino and you just want to integrate that into the solution. Or maybe you want to do stuff with interrupts or very precise timing. I know it seems weird, but I actually needed this when I was building a device to control the air conditioner at home. So it's not that weird. For those cases, what do? That's not an issue really. Luckily, we already have a serial interface between the Raspberry Pi and the Arduino via Bluetooth. So we could just write to it. It's pretty simple. And we can just send like on-off commands and status and stuff like that. So on the Node.js side, it would look like this. You just connect to the port where you establish the connection. This serial device module that we are seeing here is something I wrote. It's just a small layer on top of serial port. That's what actually using Johnny 5 under the hood. It just adds some health checks, makes sure the connection is actually working. Because when you use these Bluetooth modules, you may lose connection because of the way it works. You will never find out in your program. So I'm just using this to send like ping commands and hear the response. If it's not responding, it's dead. And on the Arduino side, it's not that complicated either. I'm just here instantiating a software serial object specifying which pins is the model using. On the loop function, you will just read data that comes from that. You basically want to buffer each character. Once you have a whole command, probably delimited by \n or something like that, you just pass it to a function that can recognize the command and just do what you want to do. So, I mean, it's not Johnny 5, but it's not that complicated either. So, how does this look like? We have the Raspberry Pi acting as a central hub on our home. It's talking via their APIs with commercial products like Nest or the Echo. And it's also talking with our homemade devices via Bluetooth. So that way we can just use Johnny 5 to receive commands and send status information. So now we know what it looks like, but we haven't talked about how are we going to access it. One way, of course, would be just to deploy a web server on the Raspberry Pi and access it. But that would mean that we can only access it from within our local network. And if we want to access from outside our network, we will have to open a port on a firewall. And that's usually not a good idea. When you're building systems like this, you want to keep the attack surface as small as possible. So we're not going to do that. Instead, we're just going to deploy our web server in the cloud somewhere. And we're just going to access that safely from any network. And our Raspberry Pi is going to talk to this server via WebSockets, just sending state information and listening for commands. So a quick word on authentication / authorization. Whatever you do, please don't implement it yourself. Try to leverage stuff like OAuth, or maybe if you need more granular authorization levels, you could use some user management systems like Strongloop that's outside, or Auth0. They're also really good. But actually, true automation does not mean just to be able to remotely control your devices. I mean, somewhere on the stack, it needs to be a component that's making decisions. If it's 7 a.m., then make coffee. If it's too hot, turn the AC on. If you detect movement and you're not at home, send a push notification alert, stuff like that. So our cloud app seems like the right place to put that. It can directly access sensor information that it's not always at home, like, for instance, the GPS on a cell phone, and act on that. For instance, it could read the GPS on our phone, and if I'm approaching home, maybe like 2 blocks away, it could turn the AC on. Another factor, and this is something I left out before, is that we could also have multiple hubs, Raspberry Pi hubs at home, and they could all connect to the same cloud app on the cloud. And that cloud app could aggregate all the stuff. So in the end, it's all about home and not really automation. So home is not just a place where you happen to be living, it's what you make of that place. And it's actually an expression of yourself as the people you live with. So while generic dashboards are usually very good at showing data and providing on-off buttons, they will never provide an experience tailored just for you. So I encourage you to build your own UI. It will feel much more like home. So keeping in mind all the concepts and ideas I mentioned, I built a small proof of concept. It's called Chez Moi. It's actually comes from French. It roughly translates to at home. And it consists of a web app that you can deploy to the cloud. It has the code for the Raspberry Pi hub, and it has code also for a native Arduino device solution and another device controlling it with Johnny 5. So it's actually working in my home for several times now. So yeah, it works. But keep in mind that as a proof of concept, it's far from being complete, and it's not the idea. The idea is just to explore what you can do. So if you're thinking about starting your own home automation solution, check it out. Just go to GitHub, fork it, make it yours. For a light demo, sorry, but you have to just find me on a break. I will be more than happy to do all the demos you want, until, of course, the AC burns. And I have a lot of links you can then check out. this is how you can reach to me on GitHub or Twitter. And that's all. Thank you.